Thank you, Susanna, very much. I'm quant by background, but we try to be as least technical as possible here and to speak about something that, has been discussed, but when it comes to implementation, has seen very few implementations. So when we speak about AI, we speak about enablement of new things or enhancement of already existing methodologies and processes. What I'm going to speak about is an enhancement. And usually when you speak about an enhancement, you speak about displacing something that already exists. There are many problems with that. Of course, old methodologies have been established, especially in econometrics, been around for 70 years. A lot of Nobel Prizes have been given to methodologies that are widely established now. And also, on the other hand, it's difficult to change the processes. Okay, so even if you come with something that's very convincing methodologically, it's very difficult to change people's mindsets and what they're used to. And also, there are the regulators, of course, they have their own processes, they have to approve models, and this makes things very, very difficult. But I'll argue today that AI can change and improve this very traditional field of economic and financial forecasting. There have been some attempts, and there are many papers around how to use deep learning to make better credit risk predictions, but they have been confined mostly to the academic domain. So young data scientists, they like to experiment. I've seen all sorts of experiments, but when it comes really to implement something and to trust, this has been quite slow. But I'll argue that AI can help in macroeconomic forecasting. It's generally a difficult field. Okay, macroeconomic forecasting is statistically very inaccurate in principle. Okay, so unlike an AI algorithm that recognizes faces of cats and dogs or natural language translator, the field of economics and finance is rapidly evolving when it comes to forecasting. So data is non-stationary. Okay, language does not change in time that much. It takes years. Of course, new words are being introduced in the dictionary. People change their face as they grow old, but these are mostly stationary processes which you can manage with a great accuracy. When it comes to economics and finance and forecasting, it's very difficult. Okay, you'll never be able to achieve 99% of accuracy like in image recognition. So it's inherently very, very difficult field. So can AI help? Okay, do this. There are some methodological differences, different way of thinking. So when traditional econometrics is based on a deductive approach, you think of the economy, what drives the economy, you postulate your theory, how prices respond to interest rates, you put this in a model, okay? And you try to fit this model to data. You put forward models that you think are worth the task, mostly linear models, and you're trying to estimate your nice coefficients, okay? And you're trying to understand the properties of these coefficients. Machine learning AI, it's an inductive approach, okay? Let data speak by itself. So let's put everything, all the data that we have, let's try to understand what relationships there are in the data. And we don't postulate upfront any particular model. So we're not saying, the relationship in the data is going to be linear, or I want to put these variables in the data. We just want to take the data and run a machine learning algorithm to understand this, the relationships in the data. And we live in a big data world. Classical models, be it for credit scoring or GDP forecasting, whatever, they're based on very few variables. Linear models, very few variables. Okay, you can easily understand they're very transparent models, but they use very few variables. But we live in the information world as of today. Why not use all the data that we have around? And we are drowning in data. So how can we extract value from this data? Okay. Again, sorry for being a little bit technical. What we'll be focusing here is on the performance of the model. Okay? And this sometimes comes at the expense of transparency. Okay? There is a lot of data. If you put many variables in your model, you're kind of running the risk of stopping to understand what's going on, okay? This is why econometric models, you can see 5, 6 variables, okay, and there you can understand the sensitivity. Regulators are happy when you submit your model for approval. So all these process revolves around simplicity. But when it comes to predictive power, sometimes can be very, very weak. And I will show you an example. And machine learning comes not only with new methodologies, comes with a completely new mindset, how you approach problems. Of course, Python is the language of choice in machine learning. A lot of very powerful libraries are available for free. So the barrier to entry into this field is really, really low. Okay. Yes, what machine learning relies on is cross-validation. Okay. When you fit an econometric model, you look at the in-sample accuracy. You try to penalize for complexity. You select simple models. Okay, the so-called AIS, BIS criteria. Okay, but machine learning relies heavily on out-of-sample testing. So different sets of methodologies that have been established in other domains before for many, many years now can be brought to econometrics. Okay, so it comes with new ways of thinking machine learning and new methodologies. And these new methodologies are more suitable for big data world, unlike the previous, more traditional econometric approaches. Okay? So what we can do here. One more thing maybe. The good thing of econometrics is that you can model policy response. When you build a simple model, okay, you understand it, but what do you do with this model? Of course, you can do a prediction, but you can also model policy response. If you're a central bank, you want to know if you raise interest rates by 50 basis points, how is your exchange rate going to react, okay? So you ask normative questions like this, okay? You use the model also to craft policy responses. In machine learning, it's more difficult. You have many variables. As I said before, sometimes there is not that much transparency, okay? So I'll argue that it's always good to be midway, okay? So machine learning is not necessarily this very scary thing called deep learning, which young data scientists, they love a lot. But, deep learning is essentially a black box. It requires a lot of data, okay? You have, of course, ways to reverse engineer why a decision has been made, okay? The sharp approach, for example. But it's very difficult from the point of view of a process to have something that makes a prediction, then another process to try to understand why your model has made this prediction. But there are a lot of machine learning models that are linear, okay? They're linear, and I argue that they can do a better job when it comes to aggregating a lot of data sources and while at the same time being explainable models. So something that's very hot topic now. Well, surely you wake up to titles like this one. Everybody's asking where inflation is going to, okay? And, this will determine also the policy response. Shall we raise rates? Shall we leave them fixed, okay? How is the world today made? Are we going to find something that we saw in the 70s, period of high inflation and low growth, okay, and high growth, sorry. Shall we raise interest rates? Okay, if we do this, we're going to kill inflation, but we're going to kill growth as well, something that happened in the 70s. So answering questions like this, where is inflation heading to? They're very important, but this is just an example. Of course, machine learning and the approach I'll describe can be applied to any macro financial variable. Yeah. So what is the issue? So you see here 2 countries, and you see in the white line, you see the inflation over the past 14 years, okay? It's been going up and down. Emerging markets, they're very volatile when it comes to inflation. UK, US, they've been stable, maybe not in the last year, so we don't know what's going to happen here from the point of view of inflation. And you see the dark brown line. This is the prediction made 12 months before the date, okay? So white line is what happened, brown line is what people predicted 1 year before. So what you can notice here is prediction is highly inaccurate, especially when there are big swings of inflation, okay? What you can also see that experts or models behind them predict the same thing. They're almost flat, okay? Why is that? Can be two reasons. One is that experts are scared to make a prediction, so they just predict the long-term average, okay? Maybe they trust excessively regulators, and they say after 1 year, you know, regulators are going to tame inflation, and it's going to revert to the mean. Or they use very complex models, the so-called DSG models, dynamic stochastic general equilibrium models, and they're very complex machines, you know, with 6,000, 7,000, 10,000 variables inside, and they have mean reverting processes inside of them. So after 12 months, your best guess up to now has been, let's guess the long-term average. They never get it right. Of course, the closer you get to the day, if you're 1 week ahead of the inflation reading, you're more accurate. But as you go further and further, 2 months, 3 months, 6 months, and so on, traditional forecasts have been inaccurate. Okay. So what can we do better here? Alternative data. You might have heard this term. I describe the properties of alternative data in my book on alternative data, but roughly speaking, alternative data is data that's not, strictly speaking, financial data. So it's not data that you can download from your Bloomberg terminal. It's a little bit more difficult to find. It's unstructured, usually unstructured, but can be satellite images, can be location data from mobile phones, can be text data. So you can use web scraping services. You can download this data, structure, understand, okay? There are many, many data sources, and some of them are freely available. So why not use all these sources to make a prediction of inflation 1 year ahead and compare it to more traditional econometric models that are based on very, very few variables. So can we do better having in our hands more information? Okay. So this is an inflation model that we built, and it leverages macroeconomic and financial data. So when it comes to forecasting, I'm not saying replace all the traditional data with new, novel, alternative data. What I'm saying, why we don't augment traditional data sources with new data sources. So this model uses macroeconomic financial data. Okay, these are all free data sources. Okay. Consensus forecasts, and these are freely available, so the central bank websites, they release consensus forecasts. So this is kind of alternative data. This is what expert thinks is going to be inflation reading at the next time horizon, over 12 months in general. So we can build a web scraper generally that downloads the data automatically. It's already structured and puts it in the training set. Okay. News data. Also, there are many websites now. Now it's freely available. You can download the data and you can download the sentiment. What people talk about inflation. And you can even follow certain individuals. You can follow Andrew Bailey and what he's going to say on inflation and the sentiment behind his words. Okay? So you can follow key important people, what they think and speak about inflation. And usually there are APIs. You can easily interface to these data sources. Something that we're using that might sound weird, it is pollution data. So you might ask, what is the link between pollution and inflation? It's not really a causal link. Okay? It's a proxy variable. So if you want to build a model in general, for example, you want to predict inflation in t+1, and we have t equals 0, you can use past lags of inflation. Can I point here? You can use expert estimates, so you can use this, for example. And you can use past reading of unemployment. But unemployment usually is not available immediately. Okay, in certain countries, you get unemployment reading 2-3 months. Okay, so if you want to know what is the unemployment in Brazil, as of today, you don't know this. You have to go back as far as December, I think. Okay, so how to backfill this information? How can we understand what is the unemployment level as of today, or the level of industrial activity. Also, industrial activities indicators, they're published with some lag. This is why pollution data is freely available. You can download it every 1 hour from around the world. It covers the whole world. And it's a good proxy for industrial activity and unemployment. Okay? So there are 6 chemicals that they're being emitted in the atmosphere. And according to the type of chemical, of course, you have different readings. You can understand the level of traffic in the city, the level of energy production as well, and the level of construction. Yeah, if you have very fine dust particles, you can understand what is the level. What are people doing? Are they building? And in COVID, we saw, of course, pollution went down, on the industrial activity went down. And we detected this very early on with pollution data, which is freely available. So it's a proxy variable, for you to understand what is the level of economic activity as of today in unemployment. And there are, of course, different data sources. People speak about supply chain problems as of today. They still persist. You can use proxy indicators like the Baltic Dry Index about the freight rate level as of today, which signals what is the level of supply chain bottlenecks as of today. So all these things are put together, okay? And what you already can see, I don't know how many, let's assume you extract 30 variables from here, and you want to use them to build a model. You take these 30 variables, you put some lags, 5-4 lags, and you already have 150 variables to deal with, okay? But your data sample, you don't have infinite data, okay? You can take inflation data as back as 1970s, but that's too old. It's not relevant as of today. If you take the last 10 years of data, you want to stay relevant, so you want to have the latest snapshot. So monthly data, these are 120 data points, but you have 150 variables. It's already a problem because the number of observation is less than the number of variables. So classical methods cannot help here. Okay? If you use linear regression, it overfits, definitely. You have p-values in your linear regression that blow up. They become non-informative at all. So machine learning methods, they can help here, but while staying in the field of transparency, okay? Once you have everything set up, your training set, you can apply different methods. The one we're applying is called elastic nets. It sounds complicated, but it's extremely a simple technique. You retain transparency, okay? It automatically selects for you, with some hyperparameter optimization, of course, the most relevant variables for your problem, and it doesn't overfit, okay? But it's transparent. It's not a deep learning model where you stop understanding what's actually going on. And in building this model, I'll show you there are different APIs. You can extract this, automatically, But behind these APIs, there are other machine learning models. So if you want to understand the news data, the sentiment, either you build it yourself, but in general, when you build AI solutions, they're a chain of models, and you don't build everything yourself, If you want to build a call center, speech detection, tone, sentiment detection in a call center, you have to transform the sound into speech, to text, and from text you have to understand what is the topic of the phone call. So there are 2 models already. The first part, you can use very cheap APIs, so the transcription from audio to text. You don't have to build it yourself. It's very cheaply available. And the same applies here. You don't have to build web scrapers. You don't have to build models to understand what's the sentiment for people. So this is an assembly of models, but behind that it's important to understand that certain models, like here, they are already machine learning models, and the provider of the data already has done the task of structuring the data for you. But you see, machine learning is a little bit everywhere, especially also there is missing data. In a big data world, it's not nicely structured like in Bloomberg. You download and start doing your modeling. So especially if you use satellite images, you want to predict the earnings of retailers over the next period. They're clouds, so there is missing data. Okay, so you have to interpolate with other methods. So it becomes a little bit more complicated, and machine learning is everywhere. And this couldn't have been possible many years ago. This is possible thanks to the data revolution, machine learning revolution. Okay. Once all the things are put together, So these are different methods. We use these methods here. So I'll show one example. So we put live this model almost 1 year ago. And this is the Brazilian inflation is what happened, is the dark brown line, okay? This is the consensus, is the yellow line. You see it very flat, you know? And people are a little bit scared during COVID to predict high inflation because, you know, everybody thought COVID would be a demand shock, you know? So people were kind of reluctant to say that inflation would grow up. So there is also a human bias in the process that the machine doesn't have. Okay, so everybody said inflation in Brazil is going to be the long-term average, 4%. This is what happened, and this is the performance of the model since it went live. Okay, so you see, for more than almost 1 year, it has been tracking inflation quite closely. So we didn't override the model, so we let the model speak for itself. And there are various applications, of course, from regulatory point of view. If you're a regulator, you want to know where inflation is heading. If you're an asset manager, this is a very deep market. It's around 200 billion inflation-linked bonds in Brazil. It's a deep market. So you could have made a lot of money here. So bottom line, it's something relatively new, what I discussed. You know, there have been some attempts, a lot of academic papers, but usually they don't work in practice when you try to implement them. It's been slow, and you know there are frictions because there are well-established procedures of how we do things, even in credit scoring. You know, if you can try to use deep learning, I tried not deep learning, random forest once, but the model approval committee frowned upon this model, and you know, for regulators, it was unthinkable to approve anything close to that kind of model. But things are starting to change. So if you are an asset manager, you don't care much if the regulator is going to approve. You know, that's not part of your process. You really want to know. You really want to make profit. So what you care is about predictive power, you know. And the model will show this pretty simple here. Of course, there are other alternatives, but we think this is the best one that retains simplicity while dealing with a lot of information and big data. That's it. I'm out of time.